Hi, I'm Andy. Welcome to Narcolepsy Pumpkin. And if you haven't done already, why don't you click on subscribe, click on the bell. That way you'll get notifications about videos when I post them.
So what I'm going to do there is a very simple task. It's an asterisk tower. I've seen it used in a couple of interviews, and it's a relatively simple, or it looks to be a relatively simple problem. So we're going to start this by creating a solution in Visual Studio 2019. And I'm going to approach this test first. So the first thing I'm going to put in is a simple xUnit test project, xUnit being my test framework of choice. Just to note that other test frameworks are available. I'm just going to quickly speed this up through creating all the project just to make this a little bit quicker. And then we get ourselves into Visual Studio. So there we go. We're sort of in a starting place in Visual Studio. What we're going to look at is this asterisk tower, Kata. And the simplest way to start this is probably a 0 rows. So we'll go for the degenerate side of things first. So we'll just rename the class here. Throughout this I'm using JetBrains ReSharper, which adds some very useful tools for refactoring code on top of what's already inside Visual Studio. So I'll just rename the test to something meaningful. So the first thing we're going to do is define the number of rows we're going to have. So this first test, rows, is 0. So we're looking for the degenerate version of this, where no rows returns basically an empty array. So I'm going to use the compiler as the failing part of the test at this point. A bit of a typo there. So what we've done here is we've got a function. I'm just going to create that using the inbuilt, well, it's actually using JetBrains ReSharper. So we've created a function there. We know that return on this is not going to be an object. It's going to be an enumerable of string. So we're still failing there on the basis that it's actually throwing a not implemented exception. And also that the test isn't actually asserting anything yet. So I'm going to swap this out with returning null. So that gives us a test that's not returning what we actually want. So let's put an assert into this. In fact, we are going to use Fluent Assertions. So I'll just bin that off and we'll go and look at the NuGet package for the solution. It's in here somewhere. So you can see I've searched for it before. So Fluent Assertions, we can install that. And while we're in here, we just clear that, we can update these packages for the test framework just to be tidy. So okay, let's just skip back to where we were. So we're going to use Fluent Assertions now. So result should and then be empty. So this should fail because our function is returning null, and that's not the expected result. Using shortcut keys, so we're doing Control U for unit tests and then R for run. Just a simple shortcut to run the tests. So to make this test pass, easiest way to do it is just return an empty enumerable of string, which we can use the Enumerable class has some static methods for creating some very useful things. So an empty enumerable of string. Now our test should pass, and it does. So there we go, we've got one test passing. All we're kind of proving there is that we've got a function that returns a hard-coded enumerable of string, or an empty enumerable of string. So we need another test. So we're going to test the one row. So that's going to return an array with a single string with a single asterisk in it, which is still kind of on the degenerate side. So we're kind of duplicating code, I know that, but we can tidy all this up later. That's the reason we do refactoring. So in this case, we're going to say it should and be equivalent to, and then we're going to dynamically build an array of string with our expected return value in it. Which is just a single asterisk, all on its own. So if we run this test, it fails, which is what we expect, because there's nothing as yet in our function that does anything other than return a completely empty enumerable of strings. So the simplest way to make this test pass is to insert a simple condition. So we're going to say if the rows is 0, then so that's the behavior, so let's return an empty enumerable, and then in the case where it's not, we're going to hard code a single asterisk. So we've got conditional, it's working out whether it's 0 or 1, so that should pass our two tests. So now we need to do something a little bit more adventurous, so we're going for a third test, which is going to look pretty similar to the first two, to be fair, and we're going to look at doing 2 rows. So that 2 rows is going to return a single asterisk with padding followed by 3 asterisks underneath it. So we've got a very small tower with 2 rows. So we're going to create that test. We're going to call it test rows 2 rows returns valid array. And we're going to duplicate all the code that we've got above. So I'm just going to type rows equals 2, and then we'll have a result, and that's going to use our function, and then we're going to pass it in rows, which is 2. If I can spell rows would help. And then we're going to say that returns the equivalent of a single asterisk padded with 2 spaces. So it's just be equivalent to new array. So the first element will be a padded single asterisk, and then the second element will be 3 asterisks in a row with no padding. So now we've got a test. Now we need to correct our spelling for one. And then we've got to make this test pass. So to make this test pass, we're going to have to write a considerably bigger function. So we know that we're going to have to return multiple rows, so we're going to go out on a limb and assume that there's some level of recursion or iteration involved in generating this array of rows of asterisks. So we know we're going to return a numeral. So what we're going to do is use the range function. I'm going to use that to create effectively a list of 1 to the number of rows. Nice and simple. So that gives me something that's an enumerable that I can do a for each loop round. So we're going to add a for each loop. So we can do each of the rows from 1 to the number of rows we've passed in. So we need to generate the output for each of those rows and sort of join it together. So to think about this, we're going to have to do a bit of planning, because I couldn't think of a way of doing this without. So what we're aiming to do is have a star followed by 3 stars underneath, followed by 5 stars below that. So if we look at that, there's a mathematical equation between the row number and the number of stars in that row. And in layman's terms, we can look at that as being the row number, which we'll call n, plus, and then that's going to be the row number again, so n plus n, and then we're going to take 1 away. So just to check that all works out, 1 plus 1 minus 1 is 1. Yeah. So there's 1 row in one star in the first row. 2 plus 2 minus 1 is 3. So that gives us 3 stars in the second row. 3 plus 3 minus 1 is 5. So that seems to work out. So what we can do is we can create a variable that gives us the number of asterisks. And that's going to be row plus row minus 1. Brackets are just kind of for effect, they're completely superfluous to the equation. Just for people who are sticklers out there. So that's not the best notation. We can take that n plus n and make that 2n minus 1. That's a much better equation, so we'll change it to that. So row multiplied by 2, and then just get rid of all the rest apart from the minus 1. So there we go. We now have the number of asterisks. Now we need to know the total width, because we need to know that to do the padding. And that width is the same equation, but against the maximum row, so the number of rows. Now these two things, though there are absolutely identical equations, potentially could change for different reasons, which for that reason I'm going to leave them completely separate. So now we know how many asterisks there needs to be. We can convert that into a string. And to do that, we can just do new string and give it the character we want to use, in this case an asterisk. and the number of times we want it to repeat that. The other string we're going to need is the number of spaces we need to pad this row by. So we need to look at how many characters we need to pad. So we're going to start with the total width that we worked out before divided by 2. But that's not right because we've got a number of stars already on that row. So if it was the first row, it would be 1. So in which case we just need that to be the number of stars. So the width minus the number of stars in the row, or asterisks, sorry, and divide that by 2. So that gives you the number of spaces we need either side. In the same way as with the asterisks, we can kind of create a string of however many characters we need, padding with just using a single space. The astute among you will have noticed that on the first one I've used string interpolation, but what I'm actually going to do here is demonstrate a little bit of refactoring. I'm going to use Control R and then V to extract this as a variable. So now that string interpolation is actually using this variable s, which I'm going to change to asterisks. This is going to be a little bit scruffy for a second because I've got two variables called the same thing, but bear with me. So we're going to change that to be asterisks row, and then because we've got a string interpolation here, we can just put in the padding either side. So by just having the spaces. So there we've got, I think, everything we need to create that row. So now we need to put it into something. So again, being quick and dirty, we just create a new list of string. And then we can simply add this newly created asterisk row to it. And then we'll just change the return to return our list as opposed to the static single element array. So there we go. Run the test, Control UR, and they all pass. So we've got something that actually works, but let's be honest, it's absolutely hideous. So the first thing we're going to look at doing is going back to the tests. We have an opportunity here because there's some duplication quite clearly between these three tests. So we can refactor these to be a theory. So I already know we're going to use inline data, and we've got kind of two obvious variables, the number of rows, in this case 1, and the expected resultant array that we're using the be equivalent to. So for this first one, it's just a single asterisk. So now we've got those variables, we can use the refactoring part of ReSharper. So we can just use Control R and then P to extract the parameter. It will throw errors because it can't work out where to, refactor that parameter to, but we know we've already put them in the inline data. Do exactly the same thing with the array. So that'll replace this array with that variable, and we'll just ignore the errors. And there we go. So we've got that to be a theory. It's actually no different. So to make it a true theory, we need multiple entries. So we can take the information for the second test, so 2 rows, we can pad that and put in the 3 asterisks for the second element. So we've actually made that test below this one here completely superfluous, so just use Control W to expand out your scope. Easy way to sort of select things. So you can use Control Shift W to reduce your scope, so down to You could go from an entire function down to a single element, from a single element up to a function using Control W. And our new theory, all passes. Now, I think there's an opportunity here. We can actually do the first test that was doing empty as well. I'm just going to rename this so that it's just going to do this a more generic name because it's no longer just testing one row. We can now add in another test. This one we're going to do for number of rows 0. So we need that to return an empty array of string. And this should all pass, and it does. So we can now get rid of this first test. So again, Control W, repeat, which will expand the scope to select as we go, and just delete it. So there we go. We've got it down to one theory test that tests everything. So now we've got some tests that pass. We can look at the other side. So our implementation. How can we make this better? Now, I prefer to remove as many variable declarations as I can. So I'm going to pull each of the equations and bits and bobs out into individual functions. So I'm just going through some very simple refactorings. I've speeded the video up because otherwise it's really boring. I'm basically doing Control R and M to extract a method. So this bit of refactoring is slightly different to the rest. What I'm going to do here is introduce a tuple. So I'm actually going to return two strings at the same time. So rather than having quite a nasty reference variable, as it's actually defined now, we're going to return these two strings together as a single tuple return character. So I can take this out parameter away, because I'm now returning it as part of the actual return value. I need to make sure that what I'm passing it into is also a tuple. That's a nice bit of C# semantic sugar that allows you to basically declare two variables as a tuple in one, and then you can actually use them individually. Just tidy up the function. So there we go. Well, I can bring those in line now, so it's just returning the two results from the two separate functions as a tuple. And the keyboard shortcut to bring a function in line or a variable in line is just Control R then I. So going back just to speed it up again to get through the boring bits. It's basically more of the same refactoring, bringing things in line, moving them out into functions. Okay, I get to this point and we're going to actually use the inbuilt ReSharper, so Control and dot, and we're going to convert it to a question mark notation. I'm not quite sure what the official term is. And it just makes it a little less wordy than the if statement, because we've got a condition that's a boolean and basically two optional outputs. The true output being first and the false output being second. So the big bit now is you're going to use Control R and C to extract a class. So we're going to pull all this implementation out into its own. We're going to call it Asterisk Tower Functions. So we'll go down and select everything we want to pull out, and that's telling us that we need to make that public because that's our entry point. I'm going to put it in its own file, own class. So now all we've got in here is the tests. And we should be able to make sure that still runs now we've extracted everything. And it does. So some might argue I should have done this earlier, and I'd be inclined to agree. So we're going to actually expand out these tests. So we're going to actually add more tests to make sure this implementation, whether it needs some adjusting or whether it's actually the final solution to our problem. So doing a 3-row and run the tests, and we'll pass. So we've not had to do anything to make it do 3 rows. That's all good. So we need to do an extra one on the end here. So there'll be 7 asterisks. This is. What's the plural of asterisk? Yeah, asterisks is. Let's put the padding in. And we can try that. Oh, and we failed. So just expand this so we can actually look inside. We'll see where the test has failed. And let's pull this out. And that's saying that the number of elements don't match. It's expecting more. And that's because I've put 3 instead of 4. So that should pass now. And it does. There we go. So now we're going to move into another bit of sort of quick speeded up refactoring. Tidy all this up. So that's it. That's the set of tests that we've come up with. And this is the implementation as it stands. So I've moved everything into essentially be extension static functions with only one entry point, and there's no variables declared anywhere. Now some might say it's a bit extreme, but this is just how I like to write code.